Hello everyone, this is Mrs. Hamby again, and this video is to help refresh your memory on how to graph linear functions. So take a little minute to kind of look at this. This is called Freyr's model, and it has the vocabulary word, which is a linear function, and you guys usually know it as y equals mx plus b, but we're going to use function notation, so we're going to do f of x equals mx plus b. Okay, and that is an example of a linear function. And here's the definition. A function is linear if the rate of change, remember the rate of change, that just means your slope. So rate of change, that means slope, is constant between any two sets of points. So basically you just always have the same constant slope. The graph of a linear function is always a straight line, okay? With the exception of one line, and we'll get to that in a little bit. So here is examples. So it could be an increasing. So just to refresh your memory, this is increasing. This brown line is decreasing. It's really hard to write sideways. And so this would be if it has a positive slope. Decreasing would have a negative slope. It's a negative. And then this one is a horizontal line. So if it's a horizontal line, it's still linear, and that would mean we have a zero slope. All right, and then here are some examples in equations. So here's what you need to make sure you look at. If it's linear, the power on the x will be a power of 1. So it will have 1 there. So here it would have a 1 on that x. That's how you know it's linear. Also, we will have a constant change in our x. So that means, and a constant change in our y. So when we go from 2 to 9, we're adding 7. And then from 9 to 16, we are adding 7. And then if you look on the other side, we are adding 3. We're adding 3. So it has a constant rate of change. And the slope of this is always your y over your x. So it would be 7 over 3. That would be the slope of that. Okay. And so that's basically 3 different ways you can tell. One is based on the actual graph. One is based on the equation. And then the points on the line, you can look at the slope and make sure they're constant. And then here are some non-examples. So if we have a vertical line, that's where we have an undefined slope. So this would be undefined slope. It is not a linear function because it doesn't pass the vertical line test. And then here, this is a v, which is an absolute value function, and this is a u, which is a quadratic function. And then notice here we have a variable in the denominator, so that's not linear. We have a power 2, that's not linear, and this is in an absolute value, so that is also not linear. And then if you would look here, from here to here, we would add 6. From here to here, we would add 4. And if we go to the other side, here you would be adding 1. To here you'd be adding 1. But if we write this, 6 over 1 is not the same as 4 over 1. So we do not have a constant change. It is changing. It's different. Where here, this is the same constant change. All right, so that's just a real quick review on linear. Please make sure you're taking notes. Write any of this down because remember, you can use your notes for your tests. So anything you write down is useful for you. All right, so we're going to do this using H-charts. So I know we've graphed using y equals mx plus b, where you begin with the y-intercept and move with the slope. But we're going to use, I call them H-charts because for handy, and it also is a little more descriptive. But we also call them T-charts. So remember, there's lots of different tools available to graph. The reason why I'm going over T-charts or H-charts is because you can graph any function in the whole world using a t-chart. So there are other methods that we're going to go over, but for the most part, a t-chart works for every single type of function. And so just to refresh your memory what a t-chart is, or an h-chart, here's a t-chart where it just has x, y. An h-chart has x. We have our function in the middle, whatever that happens to be, and then y. So this is where you show work. Okay? All right, so let's go ahead and do a couple real quick examples, and then I want you to try some, and then that will be a review of graphing lines. Oh, here are the steps to graphing lines. Step 1 is to set up your H chart or your T chart, and you got to pick X values. Then your second step is once you pick your X values, you're going to plug them into the equation to find your Y values. Then once you plug in an X, get out a Y. Remember that X is your domain. So this X would be your domain. We would get out Y values, and remember the Y values is your range. And so that would be your X and Y coordinate. You would plot those points, and then you're going to connect all your points and try and identify if there are any X and Y intercepts. So remember, X-intercept is where it crosses the X-axis. That's why it intercepts the X-axis, where the Y-intercept crosses Y-axis. All right, so I'm gonna go ahead and do a couple real quick examples. Please write this down in your notes. If you do not have graph paper, I did put some on Google Classroom for you to print, or you could just do your best at trying to draw your own graph. All right, so we're gonna graph, this is called a parent function. And the reason for that is this is as easy as a line can get. Okay, you cannot graph anything easier than y equals x. And then we call it a parent function because then we put numbers in front of the x. We put numbers after the x. And but this is as basic as it gets. All right, so what I like to do is, since I know y is x, we're going to just know we're going to plug that into our function. That's our function we're plugging into. And I always like to pick my easy numbers. So the easiest numbers would be -2, -1, 0, 1, and 2. Don't ask me why there's all these lines. We don't need them. And then we're going to just take this function and we're going to plug it in. So instead of writing x, we're going to put parentheses and we're going to replace it with our domain of -2. Well, that's easy. That's just going to be -2. So then we're going to plug in to our x, -1. You don't really need this H chart, but I'm going to do it anyway. So it's really 1 times -1 because there's an imaginary 1 there. 1 times -1. But we already know timesing it by 1 doesn't change anything. So we know it's 1 times 0. It's just going to be 0. 1 times 1. It's just going to be 1. 1 times 2. So we're just basically taking that number and replacing the x, and that's 2. And we're just going to go ahead and plot these points. So we're going to plot the point -2, -2. So you're going to go left 2, down 2. -1, -1, left 1, down 1. 0, 0. 1, 1, right 1, up 1. Right 2, up 2. And then once you have those dots, you want to connect them with a nice straight line if you can. If you have a ruler, that works even better. But that is the parent function. That's as easy as a graph gets for linear. And then we're going to change it with numbers in the front, numbers at the end. But I want to point out we do have an x-intercept, our x and a y-intercept. So this point right here at 0, 0, that is your x-intercept and your y-intercept. That's the point where it crosses the x-axis and the point where it crosses the y-axis. All right, moving right along, let's kick things up a notch. Instead of having the simple, easy, basic parent function, we're going to kick it up and we're going to put a -3 at the end. Okay? So We're going to put our function here in the middle. So whatever this is our function. We're going to put in the middle. And I like to pick my favorite easy numbers, -2, -1, 0, 1, and 2. You do not have to pick these numbers. You can pick any numbers that you like. Those are my favorite because they're the smallest numbers. So wherever there is an x, we are going to replace it with that -2. So we're going to replace the x with -2. So I'm going to write -2, and then we'll write -3. I'm going to go through because I have this color, put -3, -3, -3, -3. And then we're going to change these based on what we're plugging in. So it's going to be -1, -3, 0, -3, 1, -3, 2, -3. And then you just evaluate that. -2 and -3 is -5. So that would be your output. I think we can do this in our head. It's going to be -4, -3, -2, and -1. So we're just going to go and we're going to plot those points. So it's going to be left 2, because this is our x, -2, -5. So left 2 down to -5. We're going to go left 1 down 4. We're going to go 0, don't go left or right, down to -3. Go right 1 down 2. Right 2 down 1. Make sure your graph is a line. If it's not a line, and you know it's linear, you did something wrong. Alrighty, so what I'd like for you to do on the next slide is please pause the video, try it yourself. So try this one yourself, graph it, and then unpause the video and watch it to see if you did it correctly. So I want you to try this one, your turn. And if you did something wrong, please make a note what you did wrong. All right, so here we go. We're going to go ahead, take this function, 2x plus 1, put it in the middle. Then we're going to plug in our favorite numbers, -2, -1, 0, 1, and 2. So I'm going to go ahead, rewrite this function. Wherever there's an x, I'm going to put parentheses. So whatever it is here, just replace that x with what you're going to plug in for x. So we're going to plug in -2, -1, 0, 1, and 2. Then you just evaluate that. So this is going to be, I know it looks like a negative, but it's just a 2. So it's going to be 2 times the -2, which is -4, plus 1. It's going to be -3. We're going to have a -2 plus 1 equals a -1. 2 times 0 is 0 plus 1 is 1. 2 times 1 is 2 plus 1, and so on and so forth. And once you get your dots, you're going to go ahead and plot them. So remember, this is your x coordinate, this is your y coordinate, and you're going to plot that. So you're going to go left 2, down 3, left 1, down 1, 0, 1. I'm going to go right 1, up 3, and right 2, up 5. And we're going to connect those with a nice straight line. We put arrows at the end signifying it goes forever, never, never. And remember, I forgot the last example, but remember we want to identify where it crosses the x and y axis. So our x-intercept, we're kind of guessing here, but it looks like -0.5, 0. And the y will always be 0. And then the y-intercept is going to be at 0, 1. Okay. I'm going to go ahead and go back to the other one just so we could talk about the x and y intercepts because I kind of skipped that. So here, this is our y-intercept because it crosses the y-axis, and that's at 0, -3. And this one right here is our x-intercept, and it crosses at 3, 0. All right, thanks for watching. Have a great day.